In this question, we have several examples of questions about calculating solubility, and they're all very similar with a different twist. A chemistry student is given 750 milliliters of a clear aqueous solution at 29 degrees C. He is told an unknown amount of a certain compound X is dissolved in the solution. The student allows the solution to cool to 29 degrees C. The solution remains clear. He then evaporates all the water under vacuum. A precipitate remains. The student washes and weighs the precipitate. It weighs 25.5 grams. And it wants to know, can we calculate the solubility of X at 29 degrees C? This is a lot of words, but essentially what you have is you have a 750 milliliters of solution, and it's at 29. I guess you could cool it to 29, but it's already at 29. It's clear solution. We then take that clear solution and evaporate all the water, and the remaining salt weighs 25.5 grams. Can we assume that 25.5 grams dissolves in 750 milliliters of water? Yes, we can. However, we can't actually calculate the solubility because maybe 26 grams, maybe 150 grams can dissolve in that 750 milliliters of water. We don't know because it's a clear aqueous solution. There's no precipitate in the original solution that gives us an indication that we've hit the saturation point for the solution. So in this case, it is impossible to determine the solubility of X. Let's look at this one, which is a similar thing with a slightly different twist, as I said before. A chemistry student is given 800 milliliters of a clear aqueous solution at 31 degrees C. He is told an unknown amount of a certain compound X is dissolved in the solution. The student then allows the solution to cool to 16 degrees Celsius. At that point, the student sees a precipitate has formed. He pours off the remaining liquid solution, throws away the precipitate, and evaporates the water, and finds that there's essentially 48 grams of solute left. So in this case, the student had 800 milliliters of a clear solution at 31 degrees C. He cooled it down to 16, and when it got to 16, he saw a precipitate form. That means we've reached the solubility, the saturation point, or the solubility limit of the solution. He then evaporates that solution and finds that the mass of the salt is 48 grams. So in this case, yes, you can determine the solubility limit because you see a precipitate at 16 degrees C. So you can determine the solubility at 16. In fact, it's 48 grams per 800 milliliters. So if we take 48 grams, divide by 800 milliliters, we find out that it's 0.0600 grams per milliliter. Note that this is not a significant zero, so this is 3 sig figs. So this is the answer. Note that this is in grams per milliliter. I'm guessing you can put it in other units, so just make sure that you have the correct unit symbol. Last one, a little bit different take. It says, a chemistry student adds a quantity of an unknown solid X to 2 liters of distilled water at 25 degrees C. After 10 minutes of stirring, only a little X has dissolved, meaning there's some solid X remaining in the flask. The student then drains off the solution and evaporates the water under vacuum. A precipitate is left behind. It weighs 92 grams, is essentially what this is saying. So in this case, you have the solution and you have some solid remaining because only a little of the X dissolved. So when you take that 2 liters of solution, separate it from the remaining solid, and evaporate the water, you ended up with 92 grams. So in this case, you have 92.0 grams divided by the 2.00 liters, which gives you 46.0 grams per liter. Note that this is a different unit. This is 0.0600 grams per milliliter. This is 46.0 grams per liter. These are not the same units, so make sure you put the units in properly. So yes, it is possible to calculate it in this case, and that's the answer. So note that in order to determine the solubility, you do need to see some solid in the flask. Whether you see that solid because you cool it down and you start to see a precipitate, or you see that solid because you didn't dissolve all of the solid, there was some undissolved solid in the flask, you do need to see solid. In this case up here, the solution remained clear. If the solution remains clear, you're not going to be able to determine the solubility.